Welcome to YouTube channel. Today we will be discussing about some basics for the orals in motor and MEP. So let's move on to the topic in detail. First means mean effective pressure. Mean effective pressure, it is a theoretical constant pressure which may be assumed to act on piston during power stroke. Mean effective pressure means it is a theoretical constant pressure. Theoretical constant pressure assumed to act on piston during power stroke. Okay, it is a theoretical constant pressure assumed to act on piston during power stroke. It is known as mean effective pressure. Then mean piston speed MPS. This should not be more than 10 meter per second. Mean piston speed should not be more than 10 meter per second. In one revolution, piston will travel 2 times. That is for 2 stroke. That is, suppose if we consider speed is equal to 10 rpm, that is 2sn by 60 will be equal to sn by 30. That is mean piston speed. S stroke in rpm. That means stroke in meter, rpm in rps per second. Mean piston speed, it is the average speed with which piston travel inside cylinder. Okay, mean piston speed is the average speed in which piston travels inside cylinder. The more stroke, lesser the rpm, and propeller efficiency will increase. Thermal efficiency is maximum as sufficient time for fuel to burn. Okay, mean piston speed means it is the average speed with which piston travel inside cylinder. More stroke means lesser the rpm and propeller efficiency will increase. Thermal efficiency will be maximum as sufficient time for fuel to burn. Power developed by engine is known as indicator power. Power developed by engine is known as indicator power, and power available at flywheel is known as brake power. Power available at flywheel is known as brake power. Brake power will always be less than indicator power due to friction loss. Brake power will always be less than indicator power due to friction loss. Brake power divided by indicator power into 100% will be equal to mechanical efficiency. Brake power divided by indicator power into 100% will be equal to mechanical efficiency. So power developed by engine is known as indicator power. Power available at flywheel is known as brake power. Brake power will always be less than indicator power due to friction losses. Brake power divided by indicator power into 100% will be equal to mechanical efficiency. Then we can say long stroke, super long stroke, ultra long stroke. All these are categorized based on the stroke to bore ratio. That means long stroke, super long stroke, ultra long stroke. All these are categorized on the basis of stroke to bore ratio. We can say KMC, that means short stroke engine. Their ratio is 1:2.6 stroke to bore ratio. Then LMC, long stroke engine, that means 1:3.2. Short SMC means super long stroke engine, that is 1:3.7 to 4. Then GMC means ultra long stroke, that is 1:4.7. These are all stroke to bore ratio of different engines. That means short stroke engine, long stroke engine, super long stroke engine, ultra long stroke engine. Then compression ratio, that means volume of cylinder at the beginning of compression to the volume of cylinder at the end of compression. Compression ratio means volume of cylinder at the beginning of compression to the volume of cylinder at the end of compression. More compression ratio means more thermal efficiency. More compression ratio, more thermal efficiency. More compression means at the end of compression, temperature will be high to self-ignite fuel. More compression means at the end of compression, temperature will be high to self-ignite fuel. Compression ratio means volume of cylinder at the beginning of compression to the volume of cylinder at the end of compression. More compression ratio means more thermal efficiency. More compression means at the end of compression, temperature will be high to self-ignite fuel. For 2-stroke engine, compression ratio will be 12. For 4-stroke, it is 15. And lifeboat engine, it is 18. Compression ratio. If combustion ratio is more, then engine can be started from cold easily. If combustion ratio is more, suppose here lifeboat engine it is 18, so it should be started from the cold very easily. For main engine, power developed is already high. If we have combustion ratio, Pmax will be too high and cause damage. For main engine, power developed is already high. If we have combustion ratio, then Pmax will be too high and cause damage. Air fuel ratio. Air fuel ratio means how much air required for burning of fuel. Air fuel ratio means how much air that is required for burning of fuel. We need in a case we say ideal case we say for 14.5 kilogram of air is required to burn 1 kilogram of fuel. For burning 1 kilogram of fuel, we need 14.5 kilogram of air. But in the practice, we give more air for better combustion. But in reality, we give more air for better combustion. In actual practice, we give 36.5 kilogram of air. We give 36.5 kilogram of air. Air fuel ratio means how much air required for burning of fuel. We need 14.5 kilogram of air to burn 1 kilogram of fuel. But in practice, we give more air for better combustion. In actual practice, we give 36.5 kilogram of air. Then SFOC, that means specific fuel oil consumption. Specific fuel oil consumption, that is SFOC. It is the amount of fuel in grams to produce 1 kilowatt power in 1 hour. Amount of fuel in grams to produce 1 kilowatt power in 1 hour. Unit is gram per kilowatt per hour. Unit is gram per kilowatt per hour. Better to run engine at maximum continuous rating, that is full load, as by running at maximum power, specific fuel level consumption will be reduced. Better to run the engine at MCR, that is full load, or by running at maximum power, so the specific fuel consumption will be reduced. Specific fuel consumption means it is amount of fuel in grams to produce 1 kilowatt power in 1 hour. That is gram per kilowatt per hour. It is to better to run engine at MCR, that is maximum or full load, to run by running at maximum power, specific fuel consumption will be reduced. Then flywheel, to take care of fluctuations in RPM during ideal stroke. Flywheel are used to take care of fluctuations in RPM during ideal stroke. Units more than 8 do not require a flywheel. Means units means engine 8 more than 8 cylinder, this does not require a flywheel. Units more than 8 does not require a flywheel. 4-stroke engine will have bigger flywheel with same power rating. 4-stroke engine will have bigger flywheel with same power rating. Okay, flywheel means to take care of fluctuations in RPM during initial stroke. Units more than 8 do not require a flywheel. 4-stroke engine will have bigger flywheel with the same power rating. Then firing order. Firing order means it is the order in which units will fire. Firing order means it is the order in which units will fire. Firing order to be such that so as not to overload crankshaft from one side. Firing order it should be such that it should not overload crankshaft from one side. Okay, firing order means it is the order in which units will fire, and firing order is to be such that it do not overload crankshaft from one side. So that example it is not like 1 2 3 4 5 6, it should be like 1 6 2 4 3 5 example, because it is like this. Otherwise it is provided to so as there should not be an overload of crankshaft from one side. This will be uniformly distribute power over crankshaft. This will uniformly distribute power over the crankshaft. If firing order is not proper, heavy torsional vibration will occur. If firing order is not proper, then heavy torsional vibration will occur. Firing order means it is the order in which units will fire. Firing order to be such that it will not overload a crankshaft from one side. It should be example 1 6 2 4 3 5 and all. It will uniformly distribute power over crankshaft. If firing order is not proper, heavy torsional vibration will occur. And calculation of firing power. Firing pressure acting on a piston crown area will push the piston down. If firing pressure acting on the piston crown area, that will push the piston down. That we can say P into A equal to force. Then force into distance travelled will be equal to work done. Force into distance travelled will be equal to work done. Then P into A into L equal to WD, work done. That means work done per unit time. Work done per unit time is known as power. So P into A into L into N equal to work done per unit time. Here we can say P equal to pressure, that will express in bar, A equal to area meter square, L length of stroke in meter, N means revolution, that is RPM, revolution per second and all. Thank you.